Come on. Come on, come on, come on. There we go. Have you seen a picture like this in a picture like this in chemistry?
Yeah. Molecule.
That should say figure 1. It doesn't matter. Water molecules. So this is what water looks like, and these are the water atoms. And you know from chemistry, what is water made of?
Hydrogen and oxygen.
How many of each?
2 hydrogens and 1 oxygen.
Yeah. Do you know this from chemistry? It's basic. You probably know this from middle school.
Yeah.
Yeah? Okay, so this is what water looks like. So as you know from science, things are made of atoms. You know this. But more importantly, these atoms stick together to form molecules. So a molecule is sorry, have you done this with Lorraine, what a molecule is? I'm sure you have, yeah? So what's a molecule?
A molecule is when more than one atom are chemically bonded.
Yeah. A molecule is electrically neutral, no charge, group of 2 or more atoms held together by chemical bonds. So an example of a molecule is water, H2O. 2 hydrogens bonded with 1 oxygen. We'll talk about atoms later. Can you just get this definition of a molecule, please? You got that?
Yeah.
Just the definition box. Yeah. Okay? Cool? Right. You got that, Sophie? Yep. Right. So, for example, water, what does water look like at the molecular level when it is frozen solid as ice, or when it's at room temperature, which is a liquid, or when it is a gas like steam? So these are the 3 states of matter. So if you look here, this is what water normally looks like. You can see it close together and it's moving around a lot, the molecules. When the water becomes steam, the molecules are further apart. And then when it's ice, what's the difference? What looks like the difference between ice and...
Ice has a fixed shape. Water is just everywhere.
It's locked into place, isn't it? So, you can't see the words, I don't think. Maybe I have them on the next slide. Do I? No, okay, can you... I don't know if you can see the words in the picture. Let me go back. These words are too small for you to see?
Melting, evaporation.
Yeah, but
freezing, condensation.
maybe I'll open the picture up. So anyway, when it goes from ice to water, that's melting. And then water to steam, that's evaporation. And then steam to water is condensation. And then water to ice is freezing. Now I'll zoom in so you can write those words down. Picture 2, I guess. No, picture 1. No, there. Full screen. Okay. Can you see that okay now? Yeah, you can. Actually, if you can draw that, that would be great. Try your best to draw it. Did you draw it? Beautiful pictures, please. Yeah. You got this? Great. Irene?
Yeah.
Okay. Let's continue. So, in a solid, the position of the atoms are fixed relative to each other over a long time. This is due to the friction between molecules. This friction is provided by metallic, covalent, or ionic bonds. You know these from chemistry. Only solids can be pushed on by a force without changing shape, which means that they can be resistant to deformation. Solids also tend to be strong enough to hold their own shape in a container. Solids are generally denser than liquids. Solids becoming a gas is sublimation.
Alcohol.
Yeah, now look, there's an awful lot there. Dry ice, alcohol, yeah. There's a lot there, too much for the definition. For the exam, all you need to have is the first two sentences for the exam, okay? So that's all I want you to write down. Now, if you want to watch the video later to get the rest of the definition for your notes, that's fine. But for the exam and for your studies, you only need the first two sentences, okay? So I'll just leave the first two there. Yeah? You got that? Okay. In a liquid, the molecules are attracted to other molecules strong enough to keep the molecules in contact, but not strong enough to fix them in a particular shape. The molecules can continually move. So what this means, in a liquid, there is a bond between the molecules, a force between the molecules, but it's not strong enough to keep them locked. So they want to be together, but they can still move around. So it's not strong enough to fix their structure. They can continually move. This is what you need for the exam for a liquid. Okay, so can you write this part down? Yeah? Okay. This means that liquids can flow smoothly, but not as smooth as gas. Liquids will keep their shape in a container. Liquids are usually less dense than solids, but denser than gases. Alright, in a gas, the chemical bonds are not strong enough to hold the atoms or molecules together. And from this, a gas is a collection of independent, unbounded molecules which interact mainly by collisions. So what this means is, for a gas, the molecules, they're just free. They move wherever they want, and sometimes they bump into each other, but that's all. So that's what I mean by independent. They just move wherever they want, and the only interaction is collision. So maybe they hit, but that's all. So they're not strong enough to hold the atoms or molecules together. They just move away. Okay, so if you can get that. Yeah? Okay. Yeah? So gases tend to take the shape of their container, and they're less dense than solid and liquids. Gases have smaller forces of attraction than solids and liquids. Gases becoming a solid is deposition, but you don't need these words for the exam. Okay, so this one here, it's not even a question. I just wanted to practice for vocabulary. Sohi, maybe you can try. I have some ice and I put it on a table. So if you remember your words, can you describe what happens to the ice? So you can start with, the ice is a solid and it's placed on the table. Continue. You understand what I mean, or am I confusing you? No. So I'll get you started. The ice is a solid and it's placed on the table. The sunlight heats the ice and the ice melts and becomes a liquid. What happens next? After it's a liquid? Yeah, how does it become a gas? I mean to say, what's the word for liquid to gas? Evaporate, good, yeah. So the sunlight heats the liquid water and it evaporates and becomes a gas, steam. Yeah.
But it's ice, it's solid, and it's based on
yeah.
It moves everything, right? Twilight.
Yeah.
Solid changes to liquid.
Yeah.
Right?
Yeah, so it melts. And then after that, it evaporates. Yeah. I just want you to practice your words. So you, yeah?
Only, if it's only with sunlight it evaporates, what if it's with heat and water?
Oh, it doesn't matter. Whatever the energy is. Yeah. It doesn't have to be sunlight. Yeah. I just want you to practice your vocabulary, that's all. That's all. Okay. Right, so here are your questions here. Can you snap them? So for this lesson, I'm just wanting you to practice your English. Solid, liquid, gas, melting, freezing, evaporating, condensing. You just want to learn this vocabulary. So there's some questions here that help you practice using this vocabulary. You got that? Yeah? Right. Okay. Did you get these words as well? Condensation and freezing. Yeah. Now, there's actually, I said it earlier, but it is possible to have some materials go from solid straight to gas and skip being a liquid. You gave an example of this material. Do you know dry ice? You know dry ice? Yeah. So dry ice goes from solid to gas. But also you can have gas go into solid. I don't know any material right now that does that. Do you know?
Is there a name for, I mean like...
There is.
Solid to gas.
Solid to gas is sublimation, and gas to solid is deposition. Yeah. I don't know any, I can't think of any materials that go from gas to solid. Do you want to look it up? Yeah. Before you go, let's have a quick check to see. Let me just close all of this. Did you find anything, Hareen?
Um,
Gas to solid.
yeah. Water vapor with ice, that's not.
That's lame. Nobody cares about that. From solid to from gas to solid. Examples.
Physical vapor or film. Thin layers of material known as film are deposited onto a surface in a vaporized form of the film.
What's it called? Film.
Yeah.
FILM. And what's it used for?
I have no idea.
Nah. Have you seen
To
dry
make dry ice also you have to do that, right?
the dry ice use CO2?
Yeah, frozen CO2, dry ice.
Here, we'll finish with a little dry ice video.
Oh, carbon dioxide fire extinguisher. Right?
Yes. No.
Yeah,
Yes.
okay,
Very good. Okay, that's the one actually. So, Sohi, an example of gas to solid is, you know, the fire extinguisher, you know, for fire. When you spray that, it comes out as a gas. As a solid. No, as a gas.
Oh.
It's sprayed out, you know, kind of like a gas.
But isn't it supposed to be?
I want to go from gas to
Yeah.
solid. No, that's not.
It says it turns into solid carbon dioxide.
When it hits the fire.
But it is later released as a white powder when putting out a fire.
Yes, okay. Fire extinguisher. You fire it out as a gas, and then when it hits the fire, it becomes a solid. Yeah. Okay, I guess that'll do. Anyways, we'll finish there. Is our next class next week? Next week, isn't it?
Yeah.
Yeah.